data structure in Python. First of all, what do you mean by data? Data is a collection of raw facts, and then data structure is the representation of logical relationship between these individual elements of data. And data structure is a specialized format for organizing and storing data in memory that considers not only the elements stored but also their relationship to each other. It allows us to store data, modify the data, and allow to compare the data to others. Basically, program is a combination of this data structure and the algorithms. Then these are the different types of data structure. Data structure can be categorized in two categories, that is primitive and non-primitive. Within primitive, we are having integer, float, string and boolean. And within non-primitive, we are having built-in and user-defined data structure. In built-in data structure, having list, tuple, set and dictionary. And in user-defined, having queues, stack, linked list, graph and hash maps. Let me discuss one by one. Basically, in primitive data structure like integer can store integer values, that is 23, 56 like this. And float, these are basically the data type and can store single value only. Float can store decimal values, and like string can store character values. The string is a combination of characters, and boolean can having a value in the form of true and false. Then let us discuss built-in and user-defined data structure. Basically, the data structure in non-primitive is categorized in two categories, that is built-in and user-defined. And within built-in data structure, we are having list, dictionary, tuples and sets. Basically, built-in data structure are implicit data structure that is inbuilt within the language itself. And these data structure offers a rich toolkit for managing, organizing and manipulating data in various ways. Like these are different data structure, and these data structure having some different properties that differentiate these data structure. Like list provide us dynamic flexibility, and dictionary can store the values in the key value pair, and because of this property it enables efficient key based access. Tuples are immutable, means tuples are constant. They can store constant values. If we are created the tuples, then it is impossible to add or remove values from the tuples. Then we are having sets having property of uniqueness, means set does not allow duplicacy. Every element is having single multiplicity in the sets. Then it is your choice that which type of problem you are having. You can choose the data structure according to your problem and the based on the properties of that data structure. Then these are the user-defined data structure. User-defined data structure as a collection of data types that are defined by the user in the initial stage of your coding. These data structure allow programmer to create a data type for a specific part of the program. Like these data structures are stack, queues, trees, linked list, graph, arrays, and hash maps. These data structure having some different properties we will discuss. Then firstly, we are having Python list. Python list can store multiple values in a single variable, and it is having different properties. Like list is ordered, means the elements are stored sequentially. Lists are changeable. If you are created the list, then it is possible you can add or remove element from the list. List can allow duplicate values. You can store same value multiple time in the list. And using square brackets, you are created the list. Within square brackets, we are separated the elements by commas. Then like this, you are created a list. For example, my list equals to, using square brackets, you are creating a list. Then using print statement, you are printing the list. Then for example, like this, my list equals to 1, 2, 3 example. In a list, we can store multiple elements and the data type of these elements is either same or either different, it can store the elements of same or different data types. Then these are the some methods for adding the elements in the list. Append, insert or extend method. These methods having different properties. Like using insert method, you can insert the value on the given location. You are mentioning the location and the value both within the bracket of the method. Like this list equals to apple, banana, cherry, and this list dot insert to watermelon, means on the second location you are inserting watermelon. Then using append method, you are adding the element in the last of the list, like apple, banana, cherry. If you are using this list dot append orange, that means you are adding orange after cherry. Then you are adding ABC, you are adding ABC in the last. Then using extend method, you are adding a different data structure, like you are adding different iterable object. With list you can add, you can concatenate tuple, list, set or dictionary. For example, this list equals to this and this tuple equals to this kiwi orange. And using extend method, you can add a tuple or list, you can concatenate a tuple or list like this, and when you are printing the list, that means apple, banana, cherry, kiwi and orange is concatenated with this list using extend method. Then we are having methods for deleting the element from the list, that is remove, pop and clear or delete keyword. Using remove method, in remove method you are mentioning the value for deletion. For example, apple, banana, cherry, you are mentioning banana, that means banana is deleted from the list. Then we are having clear method. Using clear method, you are deleting all the elements from the list, but the list is present, means we are having empty list as an output. Then using pop method, you are in pop method, if you are mentioning the location of the element, and if you are not mentioning the location, then by default the pop method will delete the last element. Then using delete keyword, you are deleting the specified value, means you are specifying a location, and from that specified location the value will be deleted. Then accessing the element, accessing means you are you are printing the values of a list. Then using for loop, you are printing the values like this, my list equals to 1 2 3, this is your list. And using for loop, you are printing the values one by one. And if you want to print complete list, then you can print like this, print my list, then all the element will be printed at a time. Then if you are mentioning the location, then you are mentioning the location, then this value, the value present on that location will be printed. And we are also having list slicing. If you want to print some part of a list, then from initial to the given location the values will be printed, like print my list 0 up to 2, means the value present on 0 and first location will be printed. 2 is second location, like is not included. Then if you want to print the list in reverse order, then you can mention the location like this, from -1 up to the given location the values are printed. These are some other methods that we are implementing on the list. Like using index method, you are returning the index value of a specified element. You are returning the location of the element. Then using count method, as we know in a list multiplicity is allowed, duplicate values are allowed. Then using count method, you are calculating the number of occurrence of a given element. Then using copy method, you are copy the element of a list to another list. Then using sort method, you are sorting the element of a list in ascending order. And using length function, length method, you are calculating the number of element in the list. For example, this is your list. Using sort method, your list is sorted in ascending order in alphabetic manner. Using copy method, you are copying the list, this list into my list, and when you are printing my list, the output is apple, banana, cherry. Then length is the this is the length of calculating the length of the list means it will return the total number of element present in the list. Then using index method, it will return the location. Like if we are mentioning 10, then it will return the location of 10. Then using count method, if you are counting the number of occurrence of 10, then it will return 2 as an output. Okay, now let us do this in Python. Okay, this we already done. Then this is your list. Like for example, this is your list, and when you are printing the list, then the output is this: apple, banana, cherry. And using length function, you are calculating total number of element in the list. Then using type function, you are checking the data type of a value, data type of a variable. Like this is the list, this belongs to class list. Then like this, using print function, it will print the list. Then using length function, calculate the length of the list. Okay, then as I already told that in a list we can have values of same data type as well as of different data type. Like in these list we are having, this is your string values, these are your integer values, these are your boolean values. And like in this list we are having string, boolean as well as integer also. Okay, then if you want to access independent element of the list, then you can mention the indexes of the element. This list 1, that means this element will be presented, and if you are mentioning this list 0, that means apple will be printed. In a list we can have positive locations as well as negative locations. Positive location started from 0 up to the end, and the negative location started from end up to the first element. Means this is on -1, cherry is on -1, banana is on -2, apple is on -3. Okay. Then we can have list slicing. List slicing means from 0, 1, from 2 up to the given element. Means 5 is not included here. From 2, 3 and 4. These values will be printed as an output. And if the first location is empty, that means we are printing from initial to the given location. And if the last location is empty here in list slicing, that means we are printing from given location to the last. Same in case of negative locations. Then using if statement, we are finding that the value is present in the list or not. If the statement is true, if apple is in the list, if it is true, then this statement is executed. Otherwise, this statement not executed. Then like this, we can change the values. The property of list is changeable. We can change the values from 1 to 3. That means first and second value will be replaced by blackcurrant and watermelon. Same here. First value will be replaced by banana is replaced by watermelon. Okay, we already discussed using insert method. We are inserting the value on the given location. Using append method, we are inserting the value in the last of the list. Using addition operator, we are concatenating the list. And using extend method, we are adding a list and different iterable object, either it is tuple or set or dictionary. Okay. Using remove method, these are the methods for deletion. In remove method, we are mentioning the value for removal, that is banana is deleted. In pop method, we are mentioning the location, that is -2, banana is deleted. Then if we are not mentioning the location, that means last element will be deleted. Then using delete keyword, you are deleting the value from the given location, that is apple will be deleted. And if you are not mentioning the location, then it will delete the complete list. It will delete complete list. The output is this list not present. Okay. Then using clear method, all the elements from the list will be deleted. Okay, using for, we can access all the elements of a list like this. Then these are some different methods, some other methods of a list. Using sort method, you are sorting the element. Element is sorted in alphabetic manner. And if we are having integers, integers are sorted in increasing order. But if we want to sort the element in descending order, then we can mention this list dot sort reverse equals to true. That means these elements are arranged in decreasing order, descending order. Then copy method, we can copy the element of a list into another list, my list. Then for joining two lists, we are having addition operator. It will concatenate two lists. And if you want to concatenate two lists, then we can have this option also. Now using for loop, you are using append method within a for loop. As we know, append method will add the element in the last of the list. Then using append method, you can append the element in the last of list 1, that is ABC. Then we are having 1, 2, 3. This is all about Python list. Now we are discussing tuples. Like tuple is another data structure having some different properties from list. In tuples, we can store multiple values in a single variable. But tuple are different from list. Like tuples are also ordered, but tuples are unchangeable. Lists are changeable, tuples are unchangeable. And both list and tuples allow duplicate, but tuples can be defined using parentheses. And tuples, the element of a tuples can be separated by commas. Okay. Like this, we are creating a tuple. My tuples equals to 1, 2, 3, and within braces, we are declaring a tuple and the elements are separated using commas. Print my tuple, the output will be 1, 2, 3. And if you want to access the element of a tuple, then we can access using for loop, my tuple, then all the elements will be printed. If within for loop we are using, then independent element one by one will be printed. And if we want to complete, we want to print the tuple completely, then you can mention as the name of that tuple variable. And if you want to print a single element, then you can mention like this my tuple, then mention the location of that element 0, then that element will be printed. And if you want to print the tuple from initial to the last of the location, then you can mention like this. Okay. Just implement it in Python. Like this, we already discussed. This is your tuple, apple, banana, cherry. Then print this tuple. Then if you are checking the data type, then we are having type function. Then it will return tuple. And like this, using print function, you can print the tuple. Using length function, you can calculate the number of element in a tuple. Then there is difference between a tuple and a string. If this is your tuple, but if you are having this is your string. Means if we are having a tuple, then we are separated it, we are mentioning a comma. If we are having single element in a tuple and we are having single element in a string, then we can differentiate both string and tuples like this using that comma. when we are checking the data type of this tuple, then it will return tuple. But when we are checking the data type of that X variable, it will return you string. Then when you are checking the length of the tuple, it will return 1. Okay. As in list, we are having the values of same type as well as different type. Same in tuples, we can have the values of same type as well as the values is of different types. Like this. Same, we can also have tuple slicing from second, that is this is your second element, and up to fifth element the values will be printed. Okay, then we know tuples are immutable. Tuples are unchangeable. Then if you want to change a tuple, firstly you have to change the tuple in the list. That is typecasting. You are changing the data type of the tuple. Previously X variable is your tuple, but now you are changing the data type of that X variable. Now it will be a list. Now you are changing the list. As in tuples, changes are not possible. You are changing the list, and again you are typecasting the tuple. You are typecasting list into tuple. Now you are printing the values like this. If you want to change the tuple, firstly you have to convert it into list, and then you have to change the list and again convert it into tuples. Okay, using append method, you can concatenate the values in the last of a tuple. Same, firstly convert it into list, then changes are performed, then again convert it into tuples. Using remove method, you can delete the values from the list, then again convert it into tuple. Okay, using delete keyword, you are deleting the tuple completely, and when you are trying to print the tuple, you can have that error, tuple not present, not defined. Then packing and unpacking of a tuple means, packing means in a single variable you can store multiple values using tuple declaration, and you can also unpack these values in multiple variable like this. When you are declaring A equals to Delhi 5000 agriculture, then after that city, student, type of college equals to A. That means Delhi is assigned on city, 5000 is assigned on student, and agriculture is assigned on type of college. The output is this. This is called tuple packing and unpacking. Firstly, you have to pack a tuple, pack various values in single variable, then assign that variable on multiple values. And if you want to, means if you are having less values and here we are having more values, then the element which we are having that asterisk symbol will assign all the remaining values. Like green, apple is assigned on green, yellow, banana is assigned on yellow, and all other values like cherry, strawberry, raspberry is assigned on red. Like this. Which element having that asterisk symbol assigned all the values? Like cherry is on red, pineapple is on tropic, and other values is on green. Like this. Okay. Then like this you can join tuples using addition operator, and if you want to print multiple times these elements, then you can have that my tuple equals to fruit multiply 6. Then that means these values will be printed 6 times. Okay. Next we are having sets. Same just like list and tuples, sets can store multiple values in a single variable, and these are the properties. Like sets are unordered, but list and tuples are ordered. Sets are unchangeable, same just like tuples are unchangeable. Sets do not allow duplicates, but list and tuples allow duplicates. These are some same or different properties between sets and tuples and list. Then Using curly braces, we can declare a set. This set equals to apple, banana, cherry, and the values are separated by comma. Like this: banana, cherry, apple. And sets are unordered. That means every time when you try to print the values of a set, the order will be different. And these are the some operations that we can perform on a set, like using union function. We can combine the values from different sets. Using intersection function, we can print the values that is present in both the set. Using different function, can delete the data present in both the set and output data present only in the set passed. And using symmetric difference, does the same as difference but output the data which is remaining in both the set. Like for example, like this is your set. Using curly braces, we are declaring the set. Using square braces, we are declaring the list, and using parentheses, we are declaring the tuples. The elements are separated by commas like this. And for calculating the length of a set, we are having length function. Then this is set 1. And when you are checking the data type, then it will return set. Apple, banana, cherry, we are printing the element, then it will print apple, banana, cherry. As we see, every time it will return different output as the sets are unordered. Then this is banana, we are checking. This is in is a membership operator. You are checking that banana is present in this set or not. Kiwi is present in this set or not. These are the membership operator, and the output of this operator is in the form of boolean, true and false. Okay, these are the methods for addition. For adding an element, using add method, you can add the element in the sets. And in add method, you are mentioning the value. Then like this, using update method, you can add the item from another set in the current set, like this: apple, banana, cherry. And using update method, you are combining these two sets. Then like this, using update method, you can combine a list and a set also. Means you can combine different iterable object with the set using update method. Then these are the methods for deleting the values. Like to remove the value, we are having remove method. Using remove method, you can remove the value. Like you are removing apple, and then if the item to remove does not exist, it will raise an error like this. But when you are using discard method, it will not raise an error. It will simply print your output. Here it will not print the error. It will not print the output when you are using remove method. But when you are using discard method, it will print your output if the value is not present. Then using pop method, you can delete the value. You can delete the last element like this. Using clear method, your set will be empty. We are having empty set only. And using delete keyword, your complete set will be deleted. Then for joining two sets, we are having these different methods. Using union, we are combining two sets. Means using union method, the output will be values from both the sets. Then using update method, it will concatenate the values from set 1 and 2. But the values, if we are having duplicate values, it will print it as single time only. Both union and update will exclude any duplicate items. Then next we are having intersection update. Intersection update method will keep only the item that are present in both the set. But intersection method will return a new set. It will return the already present set, like X will be the output. But the value using intersection method will be stored in different set, like this in Z. Then next we are having symmetric difference update. Using symmetric difference update method will keep only the element that are not present in both the set, like this. Apple is same, but banana, cherry and Google, Microsoft is not present in both the set. And like this method, symmetric difference update method, can store the value in already present set, but symmetric difference method having same output like symmetric difference update, but it will store the result in different set in Z. Okay, next we are having dictionary. Like dictionaries is another data structure. It will store single value, multiple values in a single variable, but it will store the value is in the form of key value pair. And dictionaries are enclosed in curly braces, and each key value pair is separated by comma. These are some properties of a dictionary, that is ordered, changeable, duplicates not allowed in dictionary. Then using curly braces, we are creating a dictionary, but this dictionary is empty. For creating a dictionary, we are inserting the values in the form of key value pair, that is 1 Python, 2 Java. Then this is your dictionary. 1 Python, 1 is the key, Python is the value, 2 is the key, Java is the value. Then for changing or adding key value pair, we are having like this. This dict equals to brand Ford, model Mustang, year 1964. If you want to change a value of any key, then you can change like this. This dict equal to year equals to 2018. Then it will print the value 2018 like this. Then for deleting a key value pair, we are having these different functions, that is pop function, which return the value that has been deleted, and pop item function to retrieve the key value pair, which return a tuple of a key value, and to clear the entire dictionary, we are having clear function. For example, this is my dict, first Python, second Java, third. First, second and third are your keys, and Python, Java, Ruby are your values. Then A equals to mydict dot pop third. That means it will return third element. That is, third is your key. It will delete Ruby. Then print value. It will print the value equals to Ruby, value of A. Then print dictionary, mydict. It will print the dictionary, the values that is currently present. Then B equals to mydict dot pop item. It will delete the key value pair, that is key value pair B, that is second Java. Okay. Then next is your clear method. It will delete the entire dictionary, means it will clear the dictionary. Now we are having empty dictionary. These are some other functions that using key function, we are getting all the keys. Using value function, we are getting all the values, and using key value pair, we are getting all the key value pair. And if you want to get the value of a specified key, then we are having get function. Using get function, you are getting the value of a specified key. Okay. Then let us do in Python. This is your dictionary. This dict equals to brand. Brand is your key. Ford is your value. Then this dict. Dictionary item are present in key value pair, like key and value. Using length function, you are calculating the length, means total number of elements. Using type function, you are returning the data type of that is dictionary. Like this, you are printing the dictionary. And using this dict model, you are printing the value of model. And using get function, you are getting the value of a specified key. And using key method, you are getting all the keys. And using value method, you are getting all the values. Then for changing the dictionary item, you are changing like this. Year equals to 1964, you are mentioning year equals to 2018. Also, we are having different methods like using update method. It will update the dictionary with the item for a given value. That is year equals to 2020. That means the value of year will be changed. Now the value of year is 2020. Like this, you are changing the value. Color equals to, like this, you are adding the value in the dictionary. You are mentioning color is your key and red is your value. Same using update method, you can also adding the value in the dictionary. Then using pop method, you are deleting the value. You are only mentioning the key and the value of specified key will be deleted. Then using pop item, you will remove the last inserted element. That is, year will be deleted from the dictionary. And using del keyword, you will remove the item with specified key value. That is, model will be, the value of model will be deleted. And if you are not mentioning any key, then it will delete the entire dictionary. Then using clear method, you can empty the dictionary. Dictionary will be present, but it will be empty. Like this, you can access all the elements from a dictionary, all the values, all the keys. Then you can copy a dictionary using copy method. Make a copy. And using dict inbuilt function, you can make a copy of a dictionary. This is your nested dictionary, dictionary within dictionary. Within my family, we are having child 1, child 2 and child 3 dictionary. Like this. Next, these are some operations on non-primitive data structure. That is traversal. Traversal means you are accessing the elements of a data structure. Insertion, you are adding the elements. Selection, you are selecting some specified value. Searching, you are searching the value. Sorting, you are sorting the value. You are arranging the value in ascending or descending order. Merging, you are combining the values, combining different data structures, and then destroy or delete, you are deleting the value. Then in non-primitive data structure, we are having arrays. Arrays is a homogeneous collection of elements, means in an array we can store the elements of same data type. It means an array can contain the values of a single type, either it is integer or float or character. Like this, these are the array indices 0, 1, 2, 3, 4, 5, and these are the array elements 2, 4, 10, 5, 15. Array element are stored sequentially on 0th location, first, second, third, fourth, fifth, like this. These are the different type of arrays. First is one-dimensional array, two-dimensional array, multi-dimensional array. An array with only one row of element is known as one-dimensional array. It can store in ascending storage location. Then in two-dimensional array, we are having the values is in the form of rows and columns. And it is also called matrix. Then in multi-dimensional array, we are having array of arrays, means multiple arrays are not bounded to a two indices or two dimension. They can include as many indices as per the need. These are the basic operations we can perform on arrays: traversing, accessing the elements; searching, you are searching a given value in a array; insertion, you are inserting the value on the specified location; deletion, you are deleting the values from the specified location; sorting, you are arranging the elements in ascending or descending order; merging, you are merging the arrays. Then let us do in Python. Like this is next is your stack. In stack is a linear data structure that follow last in first out order. Stack is also an array, but in stack we can perform insertion and deletion on a single location. In array we can insert or delete on any location, but in stack we can perform insertion and deletion on a single location. This is your stack. These are the elements, and this is your stack top. You can insert the element on stack top, or you can delete the element from stack top. For example, this is your stack. You can take the book from top of a stack and you can put a book on the top of that stack only. Then these are the different operations we can perform on stack. Using stack you can create a new stack that is empty. It needs no parameter and return an empty stack. Then using push operation you can add a new element to the top of the stack. Using pop operation you can remove the element from the stack. Using peek operation you can return the topmost element from the stack. And is empty, it will check either the stack is empty. Basically this condition is checked when you are deleting the element from the stack. If the element is present, then the value will be deleted, and if the element is not present, it will return an error that stack is empty. Then using size you can check the number of element in the stack. Let us discuss in Python. Like this is your stack. This is stack top. You can insert the item using push operation, and you can delete the item using pop operation. For example, using append function you can perform push operation. Using append you can insert the value in last of the stack, and using pop operation you can delete the last element. That is, using append 6 will be added in stack top, and using pop operation the topmost element is 6. 6 will be deleted from stack top. Next data structure is queues. Queues is basically the ordered collection of item, and like in stack we are inserting the element in topmost element, but in queues we are having two end. From front end you can delete the element, and from rear end you can insert the element. And this is FIFO, first in first out. Basically using NQ operation you can insert the element on queue, rear, and using DQ operation you can delete the element from queue, front. In the queue only two operation will be performed, that is NQ and DQ. Like this is the real life example of queue. This is a ticket window, and every person will be added in the last, and every person will be removed from the front after purchasing the ticket. These are the different types of queues. Simple queue. In previous example, this is your simple queue. Then we are having circular queue, means after first location we are having last location, or either after last location we are having first location. Then priority queue. In priority queue there are two values with every element. First is the value, second is the priority. According to the priority, the problem will be solved. Then DQ, that is double-ended queue. In double-ended queue, we are having, we can delete the element from front end as well as from rear end, and same we can insert the element in the front end as well as in the rear end. Means we can perform insertion and deletion in both the end, that is in rear and front end. Then these are the different operations that we can perform on queues. It create a using queue operation, it will create a new queue that is empty. Then NQ, it will add a new element using NQ operation on the rear of the queue. Then DQ, using DQ, it will remove the front item from the queue. Then is empty, it tests to see whether the queue is empty. Then size, it will return the number of item in the queue. Then let us discuss in. Like this is your queue. We can insert from rear end and we can delete from front end like this. Using append method, you can insert the element in the rear end. This is NQ, and using pop method, you can delete the element from front. That is 1 will be deleted and 7 will be inserted. 7 will be inserted in the rear end and 1 will be deleted from the front end using pop method. Pop method is used to delete, used to DQ, and append method used to NQ. This is for queues. Then next we are having linked list. Linked list is another data structure. In linked list we are having different nodes, and this is your head node and this is your last node. And on every node we are having two parts, that is this is your information part, or you can say data part, and this is your link part in the next part. In the link part or next part, we can have address of next node. This node can store the value in the form of pointer. It can hold the address of another node. In the first part, we are having values or information, and in the second part, we are having addresses of next node. Like this is your last node. If we are having null address, that means it is your last node. Then these are the different type of linked list, that is singly linked list, doubly linked list, or circular linked list. Like for example, this is your singly linked list. We are having a node, and in that node we are having only forward pointer. But in doubly linked list we are having a node, and in that node we are having forward pointer as well as backward pointer. Means on every node we are having the address of previous node as well as the address of next node. Next we are having circular linked list. Like in circular linked list, on the place of this null address in the last node, we are having the address of first node. Means the last node will be connected with first node. Then next, these are the different operations on linked list. You create a linked list. Traversing a linked list means we are accessing the values of a linked list by following the forward pointer. Then you are inserting an item into a linked list. There are different possibility for inserting an item. Means if you want to insert the item in front of a linked list, then you have to mention the address of previous first node in the address part of new node, and now your head will be pointing to that new node. And if you want to add the value, add the node in the last of the linked list, then it will the value of the null pointer will be changed with that new node. And if you want to add some node in between two nodes, then it will point the address of the next node. Then same in the option of deleting a node. If you are deleting the first node, either you are deleting the last node, and either you are deleting the node from in between. Accordingly, the addresses of the given node will be changed. Then searching an item in the linked list. Using searching option, you can search the item by following the forward pointer. Then merging the linked list means you are combining the different linked list. Let us discuss in Python. Like this is your linked list. This is the data structure, and in a linked list we don't have a continuous memory locations. The memory locations is accordingly the pointer, means on every node we are having address of next node, and that is some random node, that is not continuous. And using class node, you are creating a node, and in that node we are having that function to initialize a node. In that function, using that function, you are initializing a node, and that node having two parts, that is data part and the next part. Presently next part having null pointer, having none in the pointer part. Then using class linked list, it will initialize the head. Previously head is none. Now we are mentioning the head as a temporary node, and head is pointing to the temporary node like this. L list equals to linked list. Now head is pointing to node 1, and then second is pointing to having value 3, and in third node we are having value 2 like this. Head next pointing to second node, and second node having value 3. Head node pointing to 1 having value 1. Now head node pointing to second, that is having value 3, and the next part of second having pointer of third node, that is having value 2. This is your linked list 1, 3, 2. This is the order of your linked list. Using head.next equals to, you are linking first node with second node, and now you are linking second node with third node. Okay. Next we are having trees. Trees is a data structure that consisting of nodes organized as a hierarchy. Tree is a hierarchical data structure which stores the information naturally in the form of hierarchy. It is a non-linear data structure as compared to like array, linked list, stack and queues. These are the linear data structure. And these are some terminology related to trees. Means root. First is your root. Root is a special node. The entire tree is referenced with the root node. Then parent node. Parent node is an immediate predecessor of a node. Next is your child node. All immediate successor of a node are its children. Then sibling nodes with same parent are called siblings. Then path. Path is a number of successive edges from source node to the destination. Then height of a node. Height of a node represent the number of edges on the longest path between that node and a leaf. Then height of a tree. Height of a tree represent the height of its root node. Then depth of a node. Depth of a node represent the number of edges from tree's root node to the node. Degree of a node represent a number of children of a node. Edge is a connection between one node to another. It is a line between two nodes or a node or a leaf. These are the different types of trees. First is your binary tree. The tree data structure where each parent node can have at most two children is termed as binary tree. Then your binary search tree. Binary search tree is a tree data structure where we can easily maintain a sorted list of number. Then AVL tree. AVL tree is a self-balancing tree where each node maintain extra information such as balance factor whose value is either -1, 0 or +1. If we don't have the value -1, 0, +1, then we are following a rotation. Then we are having B tree. B tree is a special type of self-balancing binary search tree where each node consists of multiple keys and can have more than two children. Like for example, in Python, let us discuss. This is your tree. This is your root node. This is on level 1, on level 2, level 3. These are your leaves. These blue are siblings. These oranges node are siblings. This is your parent, and this orange is parent for these blue. These are blue, children of this orange. Like this, you are creating a node, and for a given node in binary tree, you are mentioning left and right. Left, previously left pointer and right pointer is null, and value having containing value on a given node. Then like this. Then in binary tree, we are having traversal. How we can traverse, how we can access the element of a binary tree. Then we are having in order, pre-order and post-order. In order, firstly we are traversing left subtree, then visiting root node, then we are traversing right subtree. In pre-order, we are firstly traversing root, then left subtree, right subtree. In post-order, we are traversing left subtree, right subtree, and in the last, we are traversing the root node. These are some example of in order. Like firstly, we are creating a node. Then using in order, firstly, we are accessing root node. Then we are having access of left and right child. In order, firstly access left, then access root node, then access right. In post order, firstly access left, then right, then the root node. And in pre-order, firstly access the root node, then the left child and the right child. Like this. Pre-order, this is your root node, then left child and right child, and then left of left and right of left. Like this, you are traversing. This is pre-order, this is your in order, this is your post order. Okay. Next is your graph. Graph is also a non-linear data structure just like trees, but in graph, every node is connected. Not necessary every node is connected, but we are having a circular relationship within the nodes. Like this is your node, these are your edges, and we are representing the graph in the form of G, V and E. V are vertices, E are your edges. And like tree, there is no specified root node in a graph. There is relationship between the nodes. The nodes are connected using edges. Then these are the types of graph. Directed graph. In directed graph, direction will be mentioned. Like for example, from A to B, we are traversing the graph like this. We are mentioning the direction. Then in undirected graph, direction is not present. We are following any path from any node to any node if there is any edge present between the node. Then simple graph is your simple graph. It is not having any direction, not having any weight. Weighted graph, in weighted graph, we are mentioning the weight on the edges. Like for example, we are mentioning the kilometer in between the cities. Like we are mentioning Delhi, we are mentioning the kilometer in between Delhi and Rajasthan. We are mentioning the distance between two cities, that is called weighted graph. Then connected graph, in connected graph, every node will be connected with each other. In non-connected graph, it is not necessary that every node will be connected. Like for example, in Python, let us implement, this is your graph, and we are declaring a graph like this. And if you want to print the graph in the form of rows, then you can print like this. This is graph 0, 1, 1, 0, 1, 0, 1, 1, and your output will be this. Create a graph. This is 4 vertices and 5 edges. Like this. This is your adjacency matrix representation of your graph. Then next is your hash map. Hash maps are index data structure. A hash map make use of a hash function to compute an index with a key into an array of bucket or slot. Its values are mapped to the bucket with corresponding index and the keys are unique and immutable. Like for example, think of a hash map as a cabinet having drawers with the labels of a things stored in them. And for storing the user information, considered email as a key. And we can map value corresponding to that user such as first name, last name to the bucket. Hash function is the core of implementing hash map. It takes the key and translate it to the index of a bucket in the bucket list. Ideal hashing could produce a different index for each value, but there is a possibility of collision, and if collision occur, then we can rehash the value and again we are assigning the value. When hashing given existing index, we can simply use a bucket for multiple values by appending a list or by rehashing. These are some functions for hash map. Set value, key value, insert a key value pair into the hash map. Basically, for implementing a hash map, we are using dictionary data structure. And if the value already exists in the hash map, update the value. And for get value, return the value to which specified key is mapped or no record found, then map contain mapping, no mapping for the key. Then for deleting value, using key, remove the mapping of specified key and if hash map contain the mapping for the key. For example, like in Python, this is your hash table. We are creating an empty bucket list of a given size. Then like this, we are mentioning the range using for function. For inserting the values in the hash map, we are having a function, we are declaring a function set value. Then using for getting the index from a key using hash function, we are using that hash function. We are using any hash function. We are taking a hash function for computing the key. Then this is your bucket. Then if the key is found, then you are enumerating the bucket. And if record key equals to key found true, then break. And if the bucket has same key and as the key to be inserted, update the key. Otherwise, append the key with the new key value paired to the bucket. Then return the search value with the specified key. Get the index from key. Again, we are calculating the hash value. We are again calculating the hash function. Again, we are for another value, we are calculating the hash function. We are calculating another key. And if record is not found, we are returning record is not found. And if record is found, we are returning the value of the record. Like this, we are inserting this. This is your value. We are calculating a hash table and printing the value. This is your value will be printed. Here we are mentioning the value of a hash table. If you are mentioning 10, then after 10 places, your value will be printed like this. Within these 10 places, your value will be calculating the hash value within 10 values. Every value will be assigned within these 10 values. Like this. Okay, this is all about the data structure. We discussed primitive, non-primitive data structure, and within primitive we discussed integer, float, character string, and then in non-primitive we are having built-in and user-defined. Within built-in we are having list, tuples, dictionary sets, and within user-defined we are having stack, queues, linked list, trees, and graph, hash maps. If you are having any doubt, you can ask. Thank you.